So far, the proofs that we've seen have all been direct proofs. Statement 1 implies statement 2. Statement 2 implies statement 3. Therefore, if we know statement 1 is true, statement 3 must also be true. In a proof by contradiction, we're doing something a little bit weirder. The logic goes like this. First, we assume the statement that we want is false. Based on that assumption, we prove something that's totally ridiculous. And then, since the ridiculous thing can't possibly be true, the assumption can't possibly be true. Right? The assumption that the original statement was false, that can't happen. The original statement must have been true. So here, we've got two angles formed by the intersection of two lines. Right, so we have a picture that looks like this. Right, angle A, angle B. And we want to show that at least one of these has to be smaller than 90 degrees. First, we assume that that's false. What's the opposite of at least one being smaller than 90? Well, none of them being smaller than 90. So we assume the conclusion is false. We assume this statement is false. That is, the statement, neither one measures less than 90. Sorry, 90 or less, right? Measure 90 or less. The statement, neither one measures 90 or less, we assume that's true. Okay. So, if angle A is not 90 or less, then angle A must be bigger than 90. If angle B is not 90 or less, angle B must be bigger than 90. So it says, using 1 and 2 and the addition property of inequalities. Well, then angle 1 plus angle 2 must be bigger than 90 plus 90. So angle 1 plus angle 2 must be greater than 180. On the other hand, two adjacent angles form a linear pair. Thus, the last statement contradicts the definition of right angles? No. Angle addition property? Not really. Nothing to do with triangles here. Exterior angles property? No exterior angles here. Oh, linear pair property. The linear pair property says that a linear pair of angles, their measures add up to exactly 180 degrees. Okay, so if our assumption is true, then the sum of these two measures must be more than 180. But that's absurd, because we know that the sum of the two measures is exactly 180. Therefore, the assumption is false, and the conclusion that we wanted must be true. So here we have a conclusion from our assumption, but then we say why that conclusion is absurd. The conclusion from our assumption is absurd. It cannot possibly be true. Therefore, our assumption cannot possibly be true. Our assumption is false. Therefore, the statement that we contradicted must be true. Okay, and we check this, and that's correct. So that's the idea of arguing by contradiction. We assume the conclusion is false. We figure something out based on that assumption, and then we say why the thing we figured out cannot possibly be true.